Hello guys, welcome back to my channel Maison African Motives. Still working on engineering science N3, so we are going to focus on the question paper which was actually written in February 2022. So that is the question paper there, February 22 for engineering science N3. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Maison African Motives. Okay, so we shall quickly rush to the question 5, working on the heat. So this is a part that we are going to actually focus on question number 5 on heat. So I hope every question is clear there, but it was having a total of 15 marks. Yes, everything was 15 marks there. Okay, so on 5.1, that is on heat there, we are given a 5 kg of fuel is burnt. Take note guys, is burnt for 30 minutes in a factory in Mashite. Okay, so we're given the name of the company there, which is Mapahele. 45% of the heat from the combustion process was used to heat 2.1 liter of oil. Okay, from 32 degrees Celsius up to 135 degrees Celsius. Okay, and we are given a hint that 1 liter of oil has a mass of 0.85 kgs. Determine the heat energy required for the temperature change. All right, let's just list the information that we are given here. We have got a fuel, which for this fuel, it has a mass of 5 kgs. If you consider from the information, we've got a mass of 5 kgs, and it is to be burnt in a time of 30 minutes. That is the time interval. So the time that we have in this case is 30 minutes. So we are going to do the conversions later on, but this is 30 minutes. Okay, then what do we have here? A process is used 45% of the heat from the combustion. So in this case, 45% of the heat from the combustion process was used to heat up 2.1 liter of oil. So you've got oil here. Okay, so for the oil that you are given, it is 2.1 liters. So this oil, it has got 2.1 liters. So we are supposed to find the mass from this. Okay, so how are we going to find the mass? We are given that 1 liter here of oil is a mass of 0.85 kgs from this part here. 1 liter is a mass of 0.85 kgs. Okay, so if 1 liter is equivalent to 0.85 kgs, what about this one of 2.1 liters? So you're just going to multiply by 2.1, so it's 2.1 times 0.85. Okay, so if you multiply it properly, you are going to obtain 1.785 kgs. All right, so you multiply because this one is a more. All right, then what do we have here? From 32 degrees Celsius up to 135 degrees Celsius. So this is the temperature where it was heated from. To. So from, that's your T1, to, that's your T2. From, that's your T1. So your T1 is 32 degrees Celsius. T2, that's 135 degrees Celsius. All right, that's what we have for the oil, but we are given that 45% of the heat from the combustion, which means from this fuel that was used, is the one that was used to heat this oil. So this oil was heated by 45%. So 45% was used here. We used 45% to heat up the what? To heat up the oil. So from the one that we had from the main one, we used 45%. Okay, so we are going to talk about it, this 45% concept. All right, so the first question is actually asking us to calculate the heat energy required for the complete required for the temperature change. What made it to be made us to have a temperature change, because as you can see, it raised from 2,1 up to 1,35. There is a temperature change there. So what heat was used there, the amount of heat and the heat energy which was used. Okay, so we know that when there is a temperature change, we are going to use this formula, that is 5.11. Heat Q is equal to MC, change in temperature. Okay, so this is a heat change which happened for oil. So this is for oil. So we've got the mass of oil, the specific heat capacity of oil, and the change in temperature for the oil. Okay, so let's substitute and see what you're going to have. The mass of oil, we have here the mass of oil, remember it's 1,785 multiplied by the specific heat capacity of oil. So the specific heat capacity of oil is 2000, which is actually here the specific heat capacity. Let me just try to adjust further. As you can see there, of oil is 2000, the specific heat capacity, and is 2000 joules per kg. Okay, so this one is 2000 multiplied by the change in temperature. So the change in temperature, we know that this is T2 minus T1, that is the change in temperature. So we are simply using that temperature which changed, which is your T2 minus T1. So it's 135 minus 32. Okay, so it's 135 minus 32, like this. All right, so you can actually use your calculator at once to simplify this value. So you're going to obtain something like 367,710 joules, okay, which can be in kilojoules. That's 367,710 kilojoules. Okay, so this can be the heat energy which is required for the temperature change. Remember, this is for the temperature change, guys. So you are focusing with the temperature. Okay, so someone is wondering, what about the 45%? Why are we not applying? Okay, let's see this part here. The energy given off by the fuel. Okay, so what is the energy that is given off by the fuel? What is the energy that is the fuel having? Take note that we are given that 45% of the heat from the combustion, which means from this fuel part, 45% was the one that was used to heat the oil. So if 45% was used, what about the actual percentage that was used for this fuel combustion? Okay, so we are going to take this, guys, from this amount, because this is the heat that is being used to heat what? To heat the oil. And this is equivalent to the 45% that was taken from what? That was taken from the fuel which was used there. So if this is equivalent to 45%, it means the fuel itself at its combustion, it will be at 100%. Take note, guys, it's like this. You calculate 30% of a certain value and you obtain 20. If this is 30% of a certain value, it means the value that you calculated from, it is at 100%. So 100% is the one that you calculated from. So it's the same concept with what is happening here. The heat that you used, that we calculated, it is at 45%. So it means the heat, the energy that is from the fuel is the one that was at 100%, because we took only 45% of that heat. So it will be at 100%. So using your simple proportion from your mathematics, we have 45%, which is equivalent to the one that we calculated, which is the heat that was actually taken to heat the what? To heat the oil there. So if it is 45%, therefore the one that we want is going to be 800%. So it's going to be 100% over 45 multiplied by the heat that we used, that was taken by the oil, which is the one that we have here. So it will be vice versa now. So it's this one, which is 367,710 kilojoules. Okay, so that is going to be the 800% of what, of the fuel. Okay, so this is E for the fuel. Okay, and this is 5.12. all right, so what are you going to obtain? So from your calculator, guys, if you multiply properly, you're going to obtain this whole number, 814,911,11 and so on. Okay, so you can actually write this in joules, and you can also round off to, you can at least write in kilo. So it's going to be 123, so it's 814,911 kilojoules. So remember to write in kilo, just move 3 commas, 1 2 3 like this at this point. So it's 814,911 kilojoules, which is what, which is the energy given off by fuel that is at 100%. So take note, guys, it was an involvement of the percentage there. Okay, on 5.13, the heat value of the fuel. Okay, so we want to find the heat value of the fuel. Okay, so remember, guys, the relationship that occurs when you are given the heat energy, the energy and the mass, you can find the heat value there. Okay, so this is 5.13. Let's take this formula. Remember the formula of energy, which is equivalent to mass times the heat value. So which means to find the heat value, I'm going to just divide by mass. So it's energy over the mass. So which energy am I using? The energy of the fuel, because I need the heat value of the fuel. So I'm going to take this energy given off by the fuel. Okay, and the energy given off by the fuel is this one that we just calculated. So it's 814,911 like this. Take note, guys, this is in what, in kilojoules. This one is in kilojoules. So we have got kilojoules over the time, where we know, the mass, very sorry for that, the mass that we are given of the what, of the fuel. So the mass of the fuel, we've got it here, the mass of the fuel, which is 5 kgs. Okay, so we're going to divide by 5 kgs. Okay, so if you divide properly, we are going to obtain the heat value here. If you divide these two numbers, you are going to obtain 162,982. So this is kilojoules per kg. As we can see from this part, we have kilojoules per kg. Okay, so heat value. So remember, guys, that's how you actually obtain the heat value. So sometimes you are given the heat value, sometimes you are the one who is calculating the heat value. So you see, guys, this working with questions from question papers is very important. You know what you are working with. Okay, then we have got the power given off. What is giving off this power? The fuel again. Power given off by the fuel. Take note, this fuel, guys, was burnt 5 kg in 30 minutes. So we know that power is energy over the time that is taken. Okay, so this is 5.14. Power is equivalent energy over the time that was taken. Okay, so the energy is still the same. We are still having the same energy, which is the one that we had here, the one that we substituted of 81, because we are talking about the energy of the fuel. 814,911 times 10 to the power 3, because this is kilo, all right, over the time. Remember, we are given a time or interval of time interval is 30 minutes there, if I'm not mistaken. This is 30 minutes, and the time should be in seconds. So you're supposed to make a conversion there from minutes to seconds. So how do I convert minutes to seconds? Multiply by 60. Okay, so it's going to be 30 by 60 like this. It's now in seconds. So the moment I divide this 30 by 60, I'm going to obtain 452,728, which is power that is measured in watts. So as you can see, it's a direct answer of power that you are having, which is directly watts. So there's no need for you to make further conversions of kilowatts, because that one is going to give you a decimal, so you can just write that as it is. All right, then the most interesting question now on 5.2 is that we are given that the dryness factor of a 5 kg, take note there, we have got a 5 kg weight steam is 0.90. The steam is generated at a boiler pressure of 3.4 megapascals. Okay, calculate the specific enthalpy, which is the heat energy of the following. So we are supposed to calculate the enthalpy of that 5 kg weight steam. Okay, we are given, let's just take down the information that we have in this case on 5.2. So it's a 5 kg steam where we are given the dryness factor of 0.9, and also the boiler pressure, given a pressure of 3.4 megapascals. Okay, pressure is 3.4 megapascals like this. Okay, so take note, in order for you to use the pressure, it's supposed to be in kilopascals. Okay, so you convert this to kilopascals. Remember, mega is 10 to the power 6, of which 10 to the power 6 means is 10 to the power 3 times 10 to the power 3. Remember, when you are multiplying, you add 3 plus 3 is 6. So it means this can be 3.4 times 10 to the power 3 times 10 to the power 3 like this. So this one is the one, because it's supposed to remain in kilo. So you're going to work with one of these. So 3.4 times 10 to the power of 4, which is going to give us 3,400. So you're going to have 3,400 kilopascals. Remember, we are left with another 10 to the power 3 for kilo. So you used this one, which gave you 3,400. Your pressure is supposed to be in kilopascals. Okay, so the first question is to calculate. In this case, we are required to calculate the specific enthalpy of the following. Okay, 5.21, the liquid at saturated temperature, which is HF. Okay, so this one is HF. So what you are simply doing here is to use, because HF, there is no formula that you can actually use from these ones. So you simply use the pressure that you are given versus the HF. Okay, so we know that if you are given a certain pressure, guys, you simply need to find the pressure from your booklet. So this is what you're going to do. We need a pressure of what? These are the pressures that you shall be having like this. Okay, so you'll be having pressures here. You'll be having, this will be pressure. Okay, then you've got TS, VG, HF, HFG. So this is what you're going to just do. You take your values from this part. Okay, so HF at this pressure of 3,400. So we need to go, we need to reach 3,400. Okay, so these ones are for superheated steam. That's why I'm leaving them. We do not want something for superheated. Okay, so this part here, let me try to adjust. Maybe you can see properly like this. So you need to reach 3,400. So as you can see here, pressure, like I was saying, your pressure is in kilopascals. Are you seeing that part here? Your pressure here is kilopascals. Okay, so at this pressure, if you are to take properly, I want you to consider from this booklet. Okay, you have to take properly at 3,400 here. At 3,400 like this. Okay, so at 3400 there are values that you're going to take. So let me indicate so that I will show you properly. Maybe it's going to be clear. Okay, that is at 3400 there, and these are the values which are appearing here. At 3400 you have got the saturated temperature, which is 240 comma. You have got HF, which is the one that we want to calculate here, the enthalpy that you are having, the saturated, which is, and we have got HFG, we have got HG, SF and SG. All these values that are there, and these two can be connected. Remember the relation between HG and HF, that HG, remember you must know this relationship between HG and HF, that HG is equal to HF plus HFG, like this. Okay, so it's another relationship that you're supposed to know from these two. They can add together. Okay, so the first one, we need HF, so we are going to simply take a 3400 the value of HF. Okay, so let's take the value of HF here. So HF at this value is 1040. This value here, HF here, 1040, which is kilojoules per kg. Take note about the units, kilojoules per kg. So 1042 kilojoules per kg. Okay, so this one is 1042 kilojoules per kg, per each kg. So which means for 5 kgs you multiply by 5 kgs depending with the working, but we just need the end up. So it's this one, because we wrote per kg, as we are working with 5 kgs, but it's per kg, so writing this is fine. Okay, 5.22. we need the dry steam. Okay, so the enthalpy of dry steam, which is Hg, so Hg is for dry steam. All right, so Hg it's for dry steam. So I'm just going to take, again, it's 1 mark, so guys, I'm just going to take this Hg here. Okay, so take note the Hg here is 2802. Okay, at 3400, so it's 2802 kilojoules per kg. All right, let's move on to another one, 5.23, which is at evaporation, to evaporate the liquid, which is HFG. Okay, HFG. This one is still 1 mark, guys. You just take this one, HFG, 1700 what? 1760. So we've got 1760 kilojoules per kg. But you could have used this calculation to find HF, since you have got HG and so forth. So if you see that HF is HG, it's HF. If you add this HF 1042 plus HFG, which is 2000, no, we need HFG, this one 1000, this one HFG 1760, 1760, like this. If you add these two, they are going to give you Hg, so you're going to obtain this value of Hg, which is 2802. This is what you're supposed to do to prove out this, which is kilojoule per watt per kg. So you can actually prove this. Okay, then let's move on to 5.24. 5.24, this one we have no option because it's not there, the wet steam. So we need the enthalpy of what? Of wet steam, which is H wet. Okay, so this is H wet. So this one, guys, we do not have option, because if you are to cross check here, it's not there. We don't have something like H wet there. As you can see, guys, it's not there, it does not exist. Okay, so what am I going to do? I'm going to use this formula, because we know that H wet is supposed to be in involvement with the dryness factor that we are given. So 5.24 is H wet, which is given by the formula HF plus XFG. All right, so this is the formula that you're going to take. The enthalpy that we are given when it is at saturated, then the one that you are given when it is evaporating now with the dryness factor. Okay, so it's HF. Remember HF, we've got the value of HF here, so it's just a substitution, 1042 plus X, which is our X is 0.9. So you've got 0.90 multiplied by HFG, your HFG, which is 1760. All right, so you've got the values, guys. It's a matter of your calculator, so use your calculator properly. You're going to obtain 2626, which is in kilojoules per kg. So remember, guys, this is what we have. So interesting questions actually, but you are supposed to be very used to the formulas and so forth, so, and also to take the values from what, from the table there, from the steam table. It's a steam table, so you're supposed to take values properly from the steam table. So not to miss these classes, guys, from Maison African Motives. Make sure that you become part of the family by subscribing, and also don't forget to share our videos to your friends and colleagues so that they also can actually benefit from this information that we're having from Maison African Motives. Till we meet again.